Recently, Dataproc has added Dask to its component exchange. Dask is a way to natively scale your Python code. And of course, this has led to a lot of customer questions asking, well, Chris, when do I use Dask to scale my Python versus when do I use Apache Spark to scale my Python? Because Apache Spark, it's a unified analytics engine for large-scale data processing that happens to have a couple Python interfaces, both Koalas for Pandas functionality as well as PySpark itself. So the purpose of this video is just to give you a understanding of what it means to be the unified analytics engine with Python interfaces versus scaling Python itself. And at the end here, I'm going to jump into the actual a notebook with the actual interfaces so you can see examples of both in action and compare and contrast the two. So here's the general problem that both of these frameworks are trying to solve. It's that cloud data warehouses, they are just causing data sizes to explode. Things like Google BigQuery and Snowflake had made it so much easier to manage data at scale that now data scientists who have these Python code, they want to come in and run their analysis or their algorithms against the entire set of data. And it's not that data scientists don't understand how to consume large data sets. They do. You start with creating some distributions, understand the descriptives about a table or a set of data. You then move into dimensionality reduction, and you reduce those features. You run like a PCA to figure out what's important. You remove outliers to make sure that you're working with the data that is relevant, and then you might sample to go and just take a set of the data and make sure there's plenty of techniques to go and make sure you're getting the right sample of data. However, going down that funnel just takes a lot more time, just a lot more investment for every problem. And then there's a lot of iteration in data scientists. You might want to start again or move back to a different feature reduction technique. And all of this just takes a lot more time just takes a lot more time if you're just on a single-threaded, Python environment. And that's why there's just been a lot of different open source projects recently that are focused on this distributed Python problem. This is just the growth over the last couple years of some of the open source projects and how much more attention that they're getting from users. And Dask and Spark are not the only ones here. There's also folks like Ray that have also been in this space getting a lot of traction too. So here's kind of the high level overview in my head of kind of the two frameworks. So the stars that you see are the pros, the boxes are the cons. So in Dask, I get to work with the PyData ecosystem. Necessarily, I have no new APIs, but really it's an extension of the APIs like scikit-learn and pandas and NumPy. Dask does spend a lot more time with visualization tooling. There's a lot more you can do with the hooks and extensions that it has into existing Python visualization tools. Dask does support a lot of HPC workloads. So a lot of those scientific compute applications that are running HPC or work really well with Dask. And Dask is actually commonly found on these HPC environments as a way to scale Python code. Dask can be the fastest. Fastest is definitely an overloaded term here. I don't necessarily mean price performance. I don't mean in every situation. But generally speaking, if I had to just go pedal to the metal and pick one, I would probably pick Dask, because with Dask, with a framework like Rapids, I could throw it at a 16x A100 GPU machine and just have a half a terabyte of GPU memory that this would know how to go and consume. Spark, on the other hand, it's a lot more scale out focused. It cares about a lot more things. It cares a lot more about things like availability and making sure that job can run in a certain SLA. So, there are trade-offs to that, but if I'm going to just pick, who is the fastest, I would probably go with Dask. Again, not for all situations, not for price performance, but just, how you can think about it. And then finally, Dask, as a pro, has a lot more lower-level parallelism. So if you're trying to do, your own custom model, you don't want to be limited to just what Spark has available, Dask will actually give you the tools to go out with and build your own distributed computation in Python. Now, some of the cons. There's very limited SQL and no Scala or Java at all. So if you're trying to, if you're relying on things like Uber jars to do all of your dependency management, it's not going to happen in Dask. You're going to have to go into the Python world and figure out how to, productionize virtual environments. Often with Dask, you're also going to find that you're going to use multiple different Python packages, not just even within Dask itself, because within Dask itself, they're all, different libraries and packages, but also, they call out to, native Python. And so you have to make sure that the versions that those are based on in Dask are the same ones that you're running in your Conda environment or your virtual environment. And so, if you're not coming from a Python world, that might throw you off a little bit. Now, on the Apache Spark side, some of the pros. The new Spark 3.0, it does also have GPU support directly. So there's 3 or 4 different join algorithms now that can take advantage of GPUs if you have them. So even in Spark SQL, certain methods will call out to GPUs if you have them enabled. You have a lot of legacy support, which really means a lot of ties into a Hadoop ecosystem. So if you are using tools like, Scoop or Elasticsearch or Kafka or Zookeeper or, the list goes on, that whole world, Spark is well integrated there because it got its start on Hadoop clusters. Spark is definitely the community leader right now. And where that really makes a big difference to you as the, the developer is Spark is just a lot easier to get started with, a lot easier to find the answers to your questions on Stack Overflow, a lot more, classrooms and that are out there that you can sit in and learn more about Spark. Dask is still coming up and catering more towards a lot of, what I'd say people that know what they're doing, people that want that lower level parallelism. Some of the downsides to Spark, though, a lot of the computations now, all the computations in Spark, they are expressed with that, that MapReduce pattern. And that can be limiting for today's machine learning applications. So everything in Spark, it eventually comes down to a task, which is just an embarrassingly parallel, thread of execution running on a partition of data. And if that fails, Spark just brings it right back and expects that everything's just going to move on. That might not always apply to today's machine learning use cases, things that need a lot of state or things that need to actually have computation that has, parameters that need to be updated before you can move on, that sort of thing. There's also a big reliance on the Java virtual machine with Spark. That's where it's all built off of. And so, as a Python developer, you might be writing a Python application, and then all of a sudden get a stack trace that's full of, things from both Scala and Java, and you're troubleshooting, basically, like you're debugging across 3 languages in your Python code, which can be, a little, a point of friction for a lot of Python users. And then finally, this one gets abstracted a bit if you're using a cloud-based deployment, like, Cloud Dataproc. But Spark can be a little bit more complicated to deploy. Dask, they've done a great job with, integrating right into HPC, or even there's a Kubernetes option with a, gateway that makes it pretty easy to deploy. Spark, if you're not using a cloud vendor, you're going to have a lot of setup to do on your own. If you want to know more at that level about like the frameworks and getting under the hood of the difference between the distribution, the distribution, the distributed systems themselves, I definitely recommend checking out Eric Dill's talk. Is Spark Still Relevant? You can find it on YouTube. A spoiler alert, his answer is yes, Spark is still relevant, but still a good talk if you want to know, the difference between Spark and Dask and Rapids, more from that engineering, like under the hood viewpoint. But what I'm going to talk about for the rest of this the rest of this video is just I want to give you a quick exposure into what it actually looks like from that Python developer point of view. What are the different Python interfaces into both PySpark and Dask? So both of them have a method of working with unstructured data. In PySpark, that's RDD. In Dask, that's bags. You just point it at in both situations, you point it at a file that has no structure, and then you can work with it to structure with it or run your map applications, whatever it might be. They both have the concept of DataFrames. So in Dask, it's built really around the idea of a pandas data frame. PySpark, the PySpark API itself is much more focused on how would a SQL developer go about writing Python, which might not feel very Pythonic if you're coming from that world of Python. But there is also a pandas data frame API for Spark now called Koalas that might be worth an investigation too. There's ML packages for both. In PySpark, there's Spark.ml, which is based on DataFrame, and MLlib, that is based on RDDs. But then on the Dask side, I have DaskML here, but there's actually a few different packages for machine learning, and I'll walk through the 3 different ways you can do machine learning in Dask. And for the most part, those 3 API layers, there's tons of differences if you get into the nuances and the features, but for the most part, you're going to have similar capabilities across both. Now, where there becomes more of a differentiation between Spark and Dask is in the next section. So what you see here in orange. So PySpark, definitely more focused on like business applications, BI applications, SQL applications. The Spark SQL, it's just a lot more feature rich, a lot more robust than Dask SQL. Now, Dask SQL is a relatively new project, and they have a lot of the same goals as Spark SQL. It's just that they just are not there in terms of features. Dask itself does not have any kind of SQL engine to it or something like the Catalyst. Like there's no optimizers or anything like that. There's also no streaming in Dask. Everything is just submit a computation. Where where Spark does make it pretty easy to turn directly from a data frame into a streaming data frame, and I'll show you how you do that. Now, where Dask has some benefits, it's more towards that scientific computing or that research community. So if you are, been using NumPy for years, coming from like a MATLAB type of background, you can scale that quite easily with Dask Arrays. And then Dask also gives you access to a lot lower level parallelism. Things like delays and features, which I'll show how you can take advantage of those to build your own custom Python application that can scale across a distributed cluster. And then there's just countless more ecosystem projects. And PySpark, again, they have a lot more business applications like Spark NLP or Atom for working with genomics data. And on the Dask side, a lot more focus on more GPU-based applications because Dask scales so well across a cluster of GPUs. So you'll find frameworks like Rapids that come from NVIDIA or Blazing SQL, a SQL engine that's built for GPUs. All right, so with that, let's jump in and take a look at some of these interfaces in action. So let's take a look at those 2 interfaces, Dask and Spark, side by side, and how you'd actually interact with them as a Python developer. So in both Dask and Spark, there is a little bit of setup. I'm using Dask on top of Dataproc, which is a Hadoop Spark type cluster, so it's based on Yarn. And so I'm going to import the Yarn packages. I'm going to have a distributed client, and then what I'm going to do is I'm going to set a cluster variable as the Yarn cluster coming from Dask Yarn, and then tell my client what I'm actually interacting with to use that Yarn cluster. And I'm also going to tell the cluster to dynamically scale Dask resources based on Yarn. And so that's great because that's going to hook into like our Dataproc auto-scaling. So the same way you would use other Yarn functionality is also, like with Spark, it's going to be available in Dask as well. And if you're or happen to be using some of the Jupyter extensions for Dask, they do help you automate some of this code samples where you can just quickly spin up your own, maybe Dask environment on a laptop and then auto-generate the code to pull it over. There are some easier solutions there. Now, the Spark side, what I want to do here is I'm actually going to attach to that same Dask kernel just so I can share some resources later on. But here I import, my PySpark, Spark context and Spark config, and then set the application name, and now I have a Spark context to interact with. You'll see later there is a Spark session which abstracts some of this, but I want to show you some of the lower level APIs as well, and to do that I need the lower level access instead of Spark sessions. So Dask, Well, actually, before I get started, I'm just going to pull in some data from BigQuery. Just going to do a word count from Macbeth. I don't do anything with this data. I'm just trying to get some base data to play with here. I will write this out to a JSON file, upload that to cloud storage, and again, the data. I don't do much with this data. I just standard Shakespeare data that you'll often see Hadoop demos on. I'm just going to do the same data. All right. So first thing I want to talk about with Dask is the concept of bags. This is how you would work with unstructured data. So I'm just going to read in this text, and then I'm going to apply a map function, which is just a JSON load. So it actually knows how to treat the JSON correctly because I'm mapping it to this JSON function. But this is, unstructured could be anything. I could also, if I had a CSV file, just start parsing apart the CSV, whatever it might be. Which you'll get back here. Actually, before, let me show you what that looks like. And just do a take. I can just do a take one because it's all kind of one object here. But before I get to the next part, to understand what you're looking at, what you're seeing back is that JSON file where it's basically structured as dictionaries of dictionaries, where each word into Shakespeare, and then there's another dictionary that has the actual word counts. So let me close this, clear output, and so what I'm going to do is I'm going to just take apart those two dictionaries in this map function and return another dictionary that's more in line with what I would expect to be. Just all I'm showing here is I'm structuring some unstructured data, similar way I would in a typical even MapReduce application or Hadoop application, or with RDDs and Spark. And so again, here I am. Now I actually have those that dictionary of words to word count, more along what I want. And then if I'm ready to go and actually do some kind of combination or actually do more of a reduce type operation, there's a concept in Dask of a FoldBy, which is quite similar to a PySpark like combined by key. There is a group by as well, but it's more computationally intensive. It's easier to work with, but I'll use the FoldBy here just so you can see some of the Dask specific functionality. And so the idea here is you just give it a key, which is what you're going to group on. Then you give it the binary operator that it's what you would normally pass to like a reduce operation, and then how you want to actually reduce it. And then I can go ahead and compute that to get back a data set. Look, and just a real quick to show you, these are operations that are happening on this Dataproc cluster. And so if I pull in my Yarn application server here, you'll see I'm actually running those Dask applications right. They're going to show up on, the Yarn timeline server, your Spark history, the same way your Spark jobs will. It's all integrated into Yarn. So just a side tangent there. Now back into Spark land. So now I'm back into Spark. The way Spark is going to operate on those unstructured data sets is with something, the RDDs. So I can take that exact same file that I had, and I can go ahead and pull that into the Spark context as a text file. And again, the same mapper operation with the JSON loads is going to give me a similar looking object that is a dictionary of dictionaries. I'm not going to run through and map that, but I did want to show quickly that although we talk about Dask being better for these, typically for more customizable code, at this RDD level, Spark does offer some ways to do your own distributed application. So in this case here, I'm showing that I have the ability to get into a parallelizable aggregate. So if I had my own type of objects, I could also simply pass what is the starting this is the starting point for each partition of data, and then how do I actually want to aggregate different concepts or different different objects. And so this is just a NumPy array, but I could have done that with any of custom objects. So there are some capabilities to parallelizing code within Spark RDDs as well. So back into Dask, I'm going to close this one. So that's how to work. Bags are how to do unstructured data. But most of us, the core of both of these products is definitely working on structured data, so DataFrames. And so here what I'm going to do is I'm just going to pull in that DataFrame. When I brought back that data from BigQuery, that was a Pandas DataFrame, so all I'm going to do is give it the pandas data frame that I got from BigQuery, and I have to tell it the number of partitions I want to break it up by. This is a small data set that I'm just using for testing, so it's just going to be 1. And you can see, here I am, same data set, but it's looking more like I would expect, a pandas operation looking at a notebook. And then that gives me access to just do, the type of pandas functionality that I normally expect. Operations where that look and feel a lot like pandas. In this case, I'm just looking for word counts greater than 20, and then just pulling back a single word. And because I'm pulling back that single word, if you notice what comes back here, it's actually a Dask series. So same as what you would expect to come back if you just had one listing coming back, or one variable list come back from pandas, it would be a series. Same deal here, and I get all those series computations that I would expect. And then in Dask, when I actually want to run it, it is lazily executed, similar to the way Spark is. So I actually want to tell Dask to go and do some work. I call compute specifically, and you can see my aggregation that came back there. Looking at that in Spark, Spark DataFrames. In this is where I'm going to set up that Spark session that I talked about before. I just create a data frame off of that same pandas operation. You want to see what it looks like. Here's the operations that I'm doing in a PySpark environment. It does not necessarily look like that pandas functions that you're used to. It looks to me, my opinion on this is the PySpark data frames look a lot more like a traditional SQL statement where I'm doing a where, a group by, the sum, and then again the same way I would call compute in Dask, I'm calling show in Spark to tell it to go bring back some data or actually do some computation. So same idea. But one thing to point out here is that there is a newer API in Spark as well called Koalas. And the Koalas API, same idea, I can pull in the data from pandas, and this time I can do SQL, I can do that pandas-like functionality on top of Spark. And so that's Koalas, another library brought to you by Databricks. So let's jump into SQL now. Here's where things actually start to diverge a little bit, is when we get into SQL. So Dask, I'm importing, this is a separate package that's not part of, Dask proper, but it is another open source project where I import the context, and then I can create a table based off of that, that data frame. And I can then, once I've created this table, I've basically registered this table or created the table, I can now pull that back into a result. I pass it the SQL that I want to run against the context, and then I can compute, the result there and get back, traditional, SQL, what I expect from SQL by passing that in. On the Spark side, the way I can take a data frame, if I get stuck and I feel like, I'm not as familiar with the data frame operations, or I just wish I could pop back into SQL, I just take that exact same, data frame I was working with, and I register it as a temp table. In this case, I'll call it table Macbeth. And then I can show that, I can show here how it's, Spark now recognizes it as a temporary table. And then again, I can call out, my spark.sql, same query that you saw from the Dask side, calling show, and I'm doing my group bys on that word count and ordering. All right. So next comes, let me do the SparkML first. So SparkML, I just pulled out an example of a gradient boosted trees. For the most part, folks are gravitating towards the new Spark.ml operations that are based on that are based on the DataFrames. This is an actual ML-lib example from that is based on RDDs, but generally the idea is it's loosely based on scikit-learn framework, and so you can run these either ML-lib or Spark.ml operations at scale on really large data sets. In Dask, there's essentially 3 ways you can do machine learning. So the first way is if you have and Spark has this too, just to be clear, but I'll break it apart in Dask. So there's essentially three ways to do ML. The first is with hyperparameter optimization or some ensemble methods. So this is a situation where you have a scikit-learn model, and all you want to do is scale it, but the data sets are small enough to maybe fit in memory on a single computer. All you're trying to do is run different versions. So that's, again, perfect for like an HPO, hyperparameter optimization, where you want to pass it different hyperparameters, or maybe you just have an ensemble method where you want to pass different models across scikit-learn and have them all come back and then tell you, which is the most optimized method. You can do this with a job lib. That might be something that you've seen across, in Python before, but there's a parallel backend that's been modified for Dask, and so it knows how to actually use that, yarn cluster that you have backing you to go and do these different, to go and scale that scikit-learn. The second way you can do machine learning on Dask, and this is where you actually want to train across large data sets. Dask ML has another API for cluster, and that cluster has a handful of algorithms that are pretty common, things like k-means, where you're going to want to come in and just it knows how to actually do that algorithm on the full data set at scale. And again, you're going to find a similar parallels in Spark, where you can either scale one scale one object, or scale across a large data set with SparkML. So same thing there. Where one addition that Dask has that you would not find in Spark is, at least for now, there is a Dask XGBoost method, which will actually train the large data sets at scale using XGBoost. Very similar. The way you XGBoost parameters and results that you're expecting to work with, you'll find those there. And XGBoost is one of those that's actually a really good example of boosting algorithms. Typically, because you're training off of residuals of the past algorithm, you need it to be more serializable. So just scaling out like Spark does alone doesn't necessarily always work. So this gives you a chance to actually do a little bit different or more on Dask. Back to the Spark side. One advantage of Spark that's very different that Dask does not have is Spark does make it really easy to just take one of those existing data frames and convert it into a streaming data frame. So here, again, I'm going to import some of the streaming context, but then all I have to do is taking that same, the same way I read in that Macbeth.json file, I can now read it in as a streaming object. And it's still a JSON. The one caveat is I did have to, I had to tell it the structure so it knows what to expect coming in. But then when I go and check out that, that data frame, I can tell that it actually is a streaming data frame and it's expecting data to be coming in ongoing. And then what's pretty cool to do on top of that is with structured streaming is I can, create a query that I expect. Like maybe I want to see the words that are coming in ongoing and counting them. And I can basically take this query, this group by query, the streaming counts data frame query, and I can, what I do is I take that data frame, I tell it to write out as a stream, I'm just going to write it into memory, but I could write that to a file or to like anything that has a JDBC connection, and that way, what it lets me do is once I've created that object, now I can see it as a table, and so I can see this counts, and then I can call queries directly against that count on streaming data coming in, and all that was, within the same DataFrame framework, making it all look, pretty fluid between going from, batch to streaming within Spark. And again, Dask, is not, everything today is submission. It doesn't have that idea of a continuous stream coming in. Okay, so back to Dask. Now, here's something that's different than Spark, which you're not going to find, is this idea of arrays. So a Dask array is built off of NumPy. So if you come from, the world of MATLAB, done a lot of scientific computing, or have a, computational background, you're probably familiar with NumPy and use it quite a bit. And so you can see, real quick, NumPy functionality that you'd expect to works, at scale here. And so, what you're seeing back here is I just created a random bit of computation. This has not actually been running, but it just has an idea of, okay, what is this, NumPy array going to look like across Dask? It's not really NumPy, it's a, Dask array, but a Dask array is arrays of, distributed NumPy. And again, same functionality that you would expect to be working in NumPy, gonna work the same way across across now a cluster instead of just on a single machine. And that NumPy, what I found is, it doesn't have all of NumPy, but they have focused on a couple particular areas, one being signal processing, where, it has a lot of fast Fourier transforms that you can take advantage of. So I think they're getting, traction with, signal processing, a lot of electrical engineering applications, that sort of thing. And then obviously a lot of, just working with, linear algebra is where you're going to get a lot of advantages there. This is just a complete tangent. It has nothing to do with Spark or Dask, but because we were talking about NumPy, I just wanted to also, if you are interested in how to scale NumPy, how to do more with, NumPy operations more in the linear algebra world, a package you might want to check out is JAX. It's actually an open source project that was done by Google, but what they're designed to do is, again, NumPy across a distributed cluster, really focused on GPUs first, but does work on CPUs as well. And it has a lot of it has a lot of support for things like autograd and computing gradients, and it even has higher order gradient support. So that's derivatives of derivatives, and what that really could open up here is algorithms that are based on like forward propagation, because you can actually take those derivatives of derivatives. So again, just a side tangent. This is not doing JAX any justice, but something that you might want to check out in addition to Dask if you are interested in NumPy and doing NumPy at scale. All right, so the last piece here on Dask and a very cool differentiator over Spark is this idea of lower level customizations. So when you do want to build your own, Python code, and you need that, that lazy execution that you're finding in like building graphs of your own code, Dask lets you do that relatively easily. Essentially, what you can do is you just put these. There's a couple ways to do it, but the example I'm showing here is I can take some algorithms that I've developed, and I'm doing really simple things, but this could be anything. Put in a decorator of Dask delayed on top of it. And then what that does is it lets a Dask client understand how these are actually being built. So let's say I have a Fibonacci sequence that's, the first part that runs. And then I have another, for loop that's just going through that Macbeth data and just taking the length of each row. And let's say I need to run both of those in parallel first. And then I'll finally combine those and just, have one result that's just as, A plus B. So what I do is once I've made these all delayed, I can actually visualize the graph that gets built there. And so I have my for loop, I can have my Fibonacci sequence, both wait, and then get combined, and then I have my end result. And so that's how I can go about building my own, very customized distributed system of code for Python. And another thing that you can do is you can also submit background tasks using this idea of futures. So here, let me just have something that just goes and sums up numbers in a range. And if I wanted to maybe call that in a background task, I could just submit that to the client along with the variable that I'm actually passing in. And then what I get back is I actually get back a future. This is already finished already because it's a very trivial example. But if you had a lot of some data processing tasks that you just want to send off while you continue on your work, you can do that and then check back and you can see the status finished. And then when you actually want to block on it or get the result, you just call result. And again, another place where this is handy is, in addition to just submitting the code, I can also map the code, where I call against that same data frame, but I could call it, or that same function rather, but I can call multiple values. So here I can call it 1 through 5 and get that all to run in the background for me. So again, something like hyperparameter tuning, perfect for that. Okay, so with that, that was a very whirlwind tour of both, all the APIs that are available in Dask as well as Spark. And so, just some final thoughts here. On your next project, when you're thinking about, should I go Dask or go Spark, or when do I incorporate Dask? My take on it is for Dask, it's really for those with, a lot of Python expertise. You're dealing with a lot of, package dependencies and typical things that you would find in Python. If you're, know your way around virtual environments and have good ways to productionize those, it won't scare you away. But just something that, very much to be aware of. You really should think about Dask when you need that level of customization, where it's not something that's already been built into these higher level APIs that you can't do on your own. You have your own, weather application that you've developed or something like that. Dask could also be handy when performance matters, and caveat there, you got access to GPUs. And I really did not talk about rapids and GPUs and those integrations in this. I really just wanted to show the core APIs that are associated with Dask. But if you have access to GPUs and performance as a factor, that's another place to start looking for Dask. SQL, on the other hand, if your project is mostly about just the standard SQL or data manipulation or data retrieval task, Spark is probably the one that you want to go for. So less on the scientific computing, more on that business intelligence, pulling data type of work. If your project needs streaming, definitely go Spark. And if stability is really critical, probably you want to go with Spark. It just has a lot more built in that is stable. It's a little bit more mature of a framework. You're not running into a lot of dependencies that are getting pulled out from underneath you. So, think to yourself, are you writing a paper or are you running a business? If you're writing a paper, maybe Dask is the way to go. If you're running a business, Spark is probably the way to go. If this is your first big data project, so your first project where you're actually trying to do data at scale, going against BigQuery with Python, I'd recommend going with Spark. There's just a lot more, easier getting started guides out there for you, as well as just the interface looks a little bit more like SQL, so it should be an easier adjustment versus diving into, more of a scientific computing platform or framework. But, if you are a Spark user and you are, feeling a little bit limited, you don't have to throw out Spark by any means. So, on a Dataproc cluster, you saw I'm running 2 notebooks. They're literally sharing the same kernel, the same cluster scheduler. So, it might be worth coming into Dataproc, checking out in our component exchange. We actually have a, machine learning VM where Dask is installed. Go ahead and click that, and you can get access to, here's where everything that's installed. So it should help you out. And then there should also be, just grab a code sample here and run that, and that should give you a Dataproc cluster with not just Dask but a bunch of machine learning configuration all set up, ready to go for you. So you can try both side by side. You don't necessarily have to choose. All right, thanks for watching the video.